So I want to get ready for my automation projects, and I definitely need a relay card. Something like what we see here in the front, but those blue typical Arduino style relays or homemade DIY relay cards you can get are often of poor quality. The relays die often, or maybe even being delivered in a broken state. So I started to set out to build my own one, including a Darlington array to make sure that my pins, my GPIO pins, are not overpowered or damaged in the long term. So in case you don't remember anymore what the Darlington array is, make sure to check out our video about Darlington in general, and especially about the ULN2803, which is a very common Darlington array, and we checked already how to wire it in another video, and all the basics are explained there. Next up, let's take a look at our parts, our components here on the table. We're going to use a relay by Finder, it's a very proper one, and then we have a Darlington array as an IC, we have a resistor network, we have a PCB, basically a DIY PCB where we can test everything until we have a final design that we can then go and etch, and also we have some of those terminal blocks to basically attach all the external wiring, the loads and the signals to our little relay card. Beside this, we're also having some solder tin and also obviously some metal wire to basically create our circuits on our little circuit board. Obviously we have also soldering iron, and we have all the parts in quantity. I'm always amazed about how they are delivered in those big and long tubes here, where you can have all the parts inside. You can easily pick some and play around with them. So what I always do first is I make a little chart on a whiteboard paper or whatever to understand everything on an electrical level. So having all the little pictures or little diagrams inside my part. So in the upper right corner, we're looking at the relay itself, how to wire it, how to wire the insides. And on the left hand side, we have a rough outline of the Darlington array, on the Darlington circuit. So basically we have all our inputs on the left hand side. Even though the Darlington array is capable of having 8 Darlingtons on board, we're only going to use 4 of them. Then we have ground on the bottom, so that's also how I already envision how to have the terminal blocks there. Then moving on to the Darlington array, we have the inputs on the left hand side, the ground on the left lower corner, and the right hand side we have all the loads to be attached and the COM port also to be connected to VCC, to the power supply. And then we have all our relays over here, which all need to be connected to power. I already thought about doing it this way, then I later on changed a little bit, but this chart was really just for me to understand how everything will work together. And then I took the next step to go more into a little bit of a layouting on the chart. So moving on to the wiring, I will go with 4 relays, and I will have the signals on the left hand side, and then I will actually wire the power in this way to the left. That means that I have to cross once with the signals, but I decided crossing with the signals will be easier than crossing with the power. And then on the right hand side we have the inputs and the outputs of the relays. Also here, this is not randomly chosen the position here somewhere in the middle, it's actually where the connections, where the terminals of the relays are located on the relay itself. So it's always on the left middle where you have the input, and on the right lower corner where you have the output. Obviously at this point I should make a proper layout, or at least a circuit plan, but for me it's all about prototyping at the moment. So I will go ahead and solder everything together and see how it goes while soldering. And as soon as everything is tested, then I will move on to make a proper layout, and then afterwards producing the PCB, etching the PCB, or printing the PCB, whatever is the most convenient. And then in the next step, producing a couple of those boards that I have some available for whatever project comes up. So before we dive into the build, maybe a quick side note why using a Darlington array. First of all, it's to protect the GPIO pins from being overpowered. It's very useful to have a Darlington array in between, because the Darlington array is basically providing the load to switch on and off the relay, which in itself has a coil, and this coil will spark with very high currents at the beginning by turning on and off, which could in the long term damage your GPIO pins. So the plan is basically to connect the GPIOs here from your microcontroller, whatever it is, if it's an ESP32, Arduino, or Raspberry Pi, whatever it is, connect this into the Darlington array, and then the Darlington array doing the, let's say, the medium lifting with the coils and the relays, and then the relays themselves doing the heavy lifting with everything, no matter if it's 12 volt, 48 volts, or even the relays themselves are capable of 250 volts as a maximum. So this would be all flexible from there, obviously, depending if you're allowed to work with those voltages or not. But one of the main reasons working with a Darlington array is also that you can have basically a DC-DC conversion, because this Darlington array can be turned off and on with basically all the common low voltages. So 3.3 volts are already enough to turn this Darlington array on and off. This provides us with the flexibility to have a relay in the background that needs, let's say, 12 volt as a minimum or 24 volts as a minimum. Quite often relays, and especially industrial or in-cabinet relays, those guys need normally 24 volts. So this is something that I can't provide with my ESP or whatever. Obviously a DC-DC converter, a step-up converter would also do the job, but it's just a double use here of the Darlington array. Having a step-up, having the flexibility to whatever I want to connect here on the right-hand side, on the load side, and also having the protection for my GPIO pins. So next step, I basically arranged all the components on the circuit board in the way I envision it. So we will have the inputs here on the left-hand side, and we will have the outputs on the right-hand side. I think this is a quite natural layout. And then we will have also power input and out and ground on the left-hand side for the circuit itself. And yeah, let's start soldering. Alright, we're closing up with the last solders. So basically soldering some more ground connections in place. It's always important for me to have enough ground connections available. So whatever device I want to connect to my circuit, I have the possibility to establish a common ground, which is super important to have to ensure proper switching properties and proper logic levels. As you can see, it got a little bit messy, so that's quite some intersections I have here on the board, and also it was very tight to wire and also basically solder everything to the board with this metal wire. But that's all none of my concern at the moment. It's okay that it's pretty messy, it's just a prototype, and I want to have a quick result, and afterwards I can then perform a proper layout, maybe rearranging some components afterwards, but also just by having proper circuits on a circuit board, copper circuits on a circuit board, will improve the layout already a lot, because obviously here soldering different wires together, having intersections, soldered intersections of metal wire, this is consuming a lot of space on the circuit, and actually the components, the pins of the components are sometimes too close by to make it very difficult to wire in another or to solder in another metal wire, while when it's all on a proper circuit board, edged circuit board, we will obviously consume way less space at those intersections and way less space at every individual solder point, because we're soldering to the board and not to a metal wire. So that's how the final product looks like. I ran into some issues, especially with the relays, because basically the grid pattern didn't match between the circuit board and the relays. So I had basically to bend some of the pins of the relays. Some broke, so I had to basically solder some extra wire to the pin to re-establish this pin basically and make it possible to still use the relay. This is all shitty stuff that I won't be needed to do on a proper circuit board. Of course, you might say now it's first of all ugly, and secondly you can't use a red wire for a ground connection, but that's only because I had this red wire available in an isolated wire with the perfect length already, so I just used this one. Again, this is just a prototype. The proper layout will be much more proper and professional. Alright, everything is wired and we are ready for test. Quick summary: we have here our power supply, plus and minus 12 volts, or plus 12 volts and ground, and we have here the ground of our signal connected to our extra ground terminal at the top. Those 12 volts are basically needed to power the Darlington and also used to power those relays, because both can operate on a 12-volt basis. But of course you could use different voltages for those parts depending on the type of relay, and obviously the Darlington is relatively flexible once talking about voltage. So further up here we basically have a multimeter which is in a short circuit detection mode, so it will beep as soon as we have a connection between the two terminals of the multimeter. Over here we have our power supply. We have 12 volts for our power supply of our relay card and also therefore for our Darlington array. And on the right hand side we have the yellow cables. We have our 3.3 volt signal, so we're basically simulating a 3.3 signal from any microcontroller available. So let's go. Our test will work in the following order. I will always connect the multimeter to one of the output terminals, which is always basically the circuit you want to close or open, depending on whatever you want to do. And then on those 4 input terminals here, I will put on the signal one by one, and then we will hear the relay basically switching. All right, we're ready to go. Let's try the first relay. As soon as we connect here, we basically have the 3.3 volts connected to our input of our first relay. Therefore, the first output should connect, basically simulating a high signal from a microcontroller. So this is definitely working. You can hear the multimeter beeping, therefore indicating that the circuit is closed, a short circuit. And you can also hear the relay clicking or switching. Let me turn off the multimeter for a second so you can focus on the sound of the relay. All right, there we go. So this is definitely working. I will continue and test the other ones. Since I'm generally lazy, I will just put on the multimeter connection like this. There we go, it's working. Let's go on to the next one. Ready to go. Third one is working. Let's double check what is happening if we do the first one. The first one is switching, but only the third one is switching when we're going for the third input. All right, let's do the last one. Number 4 is working. If I switch one of the others, only the 4th one, the others are not engaging. The one that you heard just now, like this little toggling voice or toggling sound, was basically not because of a bad relay or something. It was just because I'm connecting here to the screw, and obviously this is not providing a stable high signal, and therefore the signal was toggling between high and low very quickly. Obviously not good for your relay, but later on obviously we will have a proper connection. So this is it for today. We basically designed or developed and quickly built our prototype relay card, including an internal or integrated Darlington array. So we are ready to use this in our Cybergarden project. That's what it's mainly for at the moment. I will use the prototype there right away to test the complete system. In the meantime, I will continue to build a proper version of this relay array or this relay card. I will make sure to document everything from a layouting perspective and production perspective of this module in a video, and afterwards making all the layouting and basically the layout files available, so you can build this one yourself at home and enjoy the same functionality of a combined relay and Darlington card in one component. Thanks for watching and see you next time.